Okay, here are the answers to the practice quiz for statistics. So I've taken the liberty of listing the data in order for number one. So I'm going to find the median first, and I'm going to do the mean last. So the median is just the middle data point. There are 10 pieces of data, so I need to look at the middle two. So the way I do it is I work from the outsides. So there's two, then there's two, there's two, there's two, and now I'm left with two middle ones. So the median is just the value in the middle of that. So 3 plus 3 is 6, divided by 2 is 3. So the median is 3. Okay? The mode are those values that show up multiple times, and it's the ones that show up the most. Well, I actually have two modes here because 0 shows up twice and 3 shows up twice. So the mode is 0 and 3. The min is easy, that's -8. The max is easy, that's 11. And the range is just the max minus the min. So 11 minus -8 is the same thing as 11 plus 8, which equals 19. So the range is 19. All right, so now let's do the mean. The mean is just all of the values added together and then divided by the number of values, which is 10. So if you add all of these values together, you get 25. And if I divide 25 by 10, I get 2.5. So the mean is 2.5. So that's question one. Question two. Construct the box and whisker diagram for the following data set. There are no outliers, so you don't have to look for outliers. Show your work. So again, I've already listed them in order, and I'm going to find the median. I'm going to start a box and whisker plot with the median. So I'm looking for the median, so I go start from the outside, just place a dot next, and then I end up with these two, 9 and 17. 9 plus 17 is 26. 26 divided by 2 equals 13. So the median, Q2, so I'm going to write over here, Q2 equals 13. Now, to find Q1 and Q3, I have to find the middle of each half of the data. I use 9 in the left set. So 9 and 125, so I've got to find the average between these two. So -50 plus -22 is -72 divided by 2 equals -36. So Q1 equals -36. For Q3, again, I use 17 for the right half, and I have 25 and 63 is the middle of that. 25 plus 63 is 88, divided by 2 equals 44. So 44 equals Q3. All right. So now I've got everything I need, because I know what the min and the max are. I got everything I need to draw my box and whisker diagram. So my min is -125. My max is 85. My Q2, the median is 13, which is closer to 85 than the 135, the 125, -125. So I'm going to place it about right here. And then Q1 is -36. So that's kind of closer to 13. So I'm going to put it like right about here. And Q4 is 44, which is about halfway between 13 and 85, actually a little more than halfway. So it's about right there. And then I close my box, draw the whiskers, and label it. So this is Q1 is -36, Q2 is 13, Q3 is 44. And there's my box and whisker plot for that data set. Number 3, we're looking for outliers. So again, we have to do the box and whisker plot. I've already found the median, Q2. So Q2 is 31. There's 11 pieces of data, so it would just be the middle piece of data, so 5 on each side. Now, when you find Q1 and Q3 in this situation, you use 31 in both sides. So I'm going to count from the left side. I'm going to go 1 and 31, 8 and 31, 22 and 29, 25 and 28. So I got to use both 25 and 28 Add that together, divide by 2. So 25 plus 28 is 53. 53 divided by 2 is 26.5. So Q1 is 26.5. Same thing's going to happen over here. I use 31 again and 64, 35 and 53. Find halfway between 37 and 41. That's going to be 39. 37 plus 41 is 78. Half of 78 is 39. 39. Okay. So what is the IQR? The IQR is Q3 minus Q1. Q3 is 39 minus Q1 is 26.5. So I'm going to put a 0 here. So do my little subtraction. So that's 5. 8 minus 6 is 2. 3 minus 2 is 1. So 12.5. The IQR is 12.5. To find the lower fence, I multiply the IQR by 1.5 and subtract it from Q1. So 1.5 times 12.5, 25, carry the 2. 5 times 2 is 10 plus 2 is 12. Carry the 1. 5 plus 1 is 5 times 1 is 5 plus 1 is 6. And then a 0, and then 5, 2, 1. Add it all together, 5, 7, 8, 18.75. So I need to take the Q1, which is 26.5, and subtract 18.75. So that's 5. 14 minus 7 is 7. 15 minus 8 is 7. So 7.75. So the lower fence is 7.75. Okay. For the upper fence, I'm going to take that same value of 18.75 and I'm going to add it to Q3. So 39.00 plus 18.75. So 5, 7, 7, and 5. 57.75. So the upper fence is 57.75. So what is my outlier? Well, my lowest term is 8, and it is greater than 7.75, so it is not an outlier. My highest term is 64, and it is more than 57.75. So 64 is the only outlier. Okay. Standard deviation. So the first thing we're going to do is we're going to find the mean of this data. So I'm going to add all this data up and divide it by 5 because there are 5 terms. So 83 plus 23 is 106. 106 plus 6 is 112. 112 plus 15 is 127. Plus 1 is 128. So 128 divided by 5. Let me do that real quick on my calculator. 128 divided by 5, 25.6. So the mean is 25.6. That is the mean. That's this. Okay. To find the standard deviation, I take each term and subtract the mean from it, then square that, add them all up, divide by the number there are, then take the square root. I know it sounds like a lot, but here's how I write it. 1 minus 25.6 squared equals 15 minus 25.6 squared equals 6 minus 25.6 squared equals 83 minus 25.6 squared equals, all right, I skipped something, 23. 23 minus 25.6 squared equals, okay. So do those real quick. And and that equals 4,403.2. All right. And we take that number and we divide it by the number of elements we had, which is 5. So 4,403.2 divided by 5 equals 880.64. And then we take the square root of that number. Square root of 880.64 equals 29, and we're rounding it to the hundredths, so 29.68. And that is the standard deviation, 29.68. All right, the last question. Describe how the standard deviation would change if the number 83 were disregarded as an outlier. So that means we take this value right here out. We don't use it. Well, if you do the math real fast, you'll find that the standard deviation for the original set was 29.68, but for the new set without 83 in it would be around 10, somewhere close to 10. So obviously the standard deviation, it will get smaller, a lot smaller. So that's the answer to number 5.